In lesson 3.6, we're going to be talking about lines in the coordinate plane. And we're going to break this lesson into two parts. And so the first part, we're going to be talking about the equations of our lines. Now, our equations can be written in different ways, and so therefore we have different forms of our equation. In our box, in the middle, you can see that we have three different forms that we're going to be talking about. The first one is the point-slope form of our equation, and just as the name says, we have a point and slope from our line. So the equation in that form looks like y minus y1 equal to m times x minus x1, where the point on our line is going to be x1, y1, with a slope of m. Now you can see on the right, I have an example of an equation written in point-slope form, and I can pretty quickly identify my slope. It would be the value substituted in for m, and the point on my line would be the number substituted in for the x1 and y1. So the point on my line would actually be negative 4, positive 2. It's the kind of the opposite sign as what's in the equation. The second equation form that we're going to look at is slope-intercept form. I happen to find that I feel most of the time kids are the most familiar with slope-intercept form. Slope-intercept form, y equals mx plus b, where, again, m is the slope of our line, and b is the y-intercept. Keeping in mind that the y-intercept is where we cross the y-axis. On the right-hand side, I can see that I have y equals 2x plus 3. It is written in slope-intercept form, where y is solved, or y is isolated. I can pretty quickly identify that my slope would be 2, and my y-intercept would be 3. And lastly, we have standard form, and the standard form of an equation reads ax plus by equal to c, where the a, b, and c are real numbers, and a and b are both non-zero. On the right-hand side, I have an example, 2x plus 3y equal to 10 in standard form. Now, when an equation is in standard form, I cannot quickly identify the slope, nor can I identify the y-intercept or a point on my line. In order to do so, I would have to do some rearranging. And so typically when we have an equation like this, we transform it into slope-intercept form. So again, here my slope would not be 2. We're going to work on writing our equations of our line. And in example A, you can see that they're going to ask us to write our equation in point-slope form. The first thing we want to remind ourselves, point-slope form is the one where we have y minus y1 equal to m times x minus x1. We are actually going to be making some substitutions for those highlighted values. And as I look at the information they give me, they tell me that my slope is negative 3/4. And they tell me it contains the point negative 2, 5. Therefore, I have m, I have x1, y1. I just need to substitute in. So, making my substitutions, I have y minus 5 equal to negative 3/4, parenthesis x minus a minus 2. Now the only thing that I'm going to tell you to do here is to simplify a little bit by changing my minus to minus. I know that that would have to be plus, so I'm going to simplify that. X plus 2. But this is my final answer for an equation of a line in point-slope form. As I look at number 2, it tells me that it passes through negative 7, 4 and 9, negative 4. So I have 2 points, but the one thing that I don't have is I don't have my slope, and that is where I'm going to have to start. So I'm first going to have to start by finding slope. We talked about it in lesson 5, y2 minus y1 over x2 minus x1. We need to be careful with our negatives. We find out here that our slope is negative 1/2. Now I have my slope, and I actually have 2 different points that I could use. If I happen to pick the first one, x1, y1, I would be using negative 7 and 4, but it also passes through the second point, and so really I could pick either point. If we pick the first one, we would end up having y minus 4 equal to negative 1/2 parenthesis x minus a minus 7 point slope form. But again, as I said, you could have picked the second point, and if you pick the second point, your equation would look something like this. So either answer would be acceptable. We know when graphing a line, there are infinitely many points on my line, and so really I could have infinitely many equations written. Here, given these 2 points, those are my 2 possibilities. Now example B asks us again to write an equation of our line, but this time they want it in slope-intercept form. And so reminding myself, I'm going to be looking to get it in form y equals mx plus b. As I look at the information that they give me, they do tell me my slope is 3, and it contains the point 0, negative 5. So again, if this is my point, I could use x1 and y1. If I have a point and a slope, I can go ahead and substitute in to my point slope equation, where we are going to say y minus a minus 5 equals 3 times the quantity x minus 0. Now, in order to get it into slope-intercept form, I actually want y by itself. And so to do that, I'm going to start by distributing y plus 5 equal to 3x. And then I'm going to take and subtract my 5. A final answer, y equal to 3x minus 5. This actually tells me that I have a slope of 3 and I cross the y-axis at negative 5. Now, you might have noticed that my given point, 0, negative 5, did actually tell me my value for b. And so if I would have recognized that initially, I could just go ahead and plug that in. But I wanted to show you that 0, negative 5 is also a point, and we could substitute and solve. In question number 2, I have a slope of 5, and it contains the point 1, negative 3. Now this is not my y-intercept, and so I am going to have to use my x1, y1 in order to solve. I'm going to use my point slope formula and make my substitutions. Now, again, I want y by itself, so I'm going to start by distributing. And then I am going to subtract my 3. Final answer here, I see I have y equal to 5x minus 8. Therefore, my slope is 5, and I cross my y-axis at 8. Now, there is another way that you could look at that. I could take my x and y value and substitute it into the slope-intercept form, finding that y equals mx plus b, and I could think about solving that equation for b. And what you can see is that I would have 5 plus b subtracted over. We would end up to find that negative 8 is b, and we would plug it in. Same answer would result. It's just another way to go about it. On the back side, taking a look at example C, I'm still writing my equations. They again want me to write in slope-intercept form. And so we are reminding ourselves that is y equals mx plus b. And as I look, number 1, it tells me that negative 10x plus 2y equals 6. So in order to get this into slope-intercept form, I need to get y by itself. The first step in order to solve for y is going to be to add 10x to both sides. We find out that 2y equals 10x minus 6. And now I'm going to divide by 2. But I have to remember on the right-hand side, I need to divide everything by 2. I end up finding that y equals 5x minus 3. If I need to identify my slope and my y-intercept, well, we can see that the slope, my number in front of x, would be 5, or 5 over 1, and my y-intercept would be a negative 3. Number 2 is similar. I need to solve for y, but in this case, I'm going to start by subtracting 3x from both sides. And I find out I have negative 5y equal to negative 3x plus 10. I will now divide by negative 5. I need to divide everything by negative 5. So when I have a negative 3 divided by negative 5, that's actually going to give me a positive 3/5. 10 divided by negative 5 is going to give me a negative 2. Identifying my slope and y-intercept, I can see my slope, positive 3/5, of y-intercept of negative 2. Now we're also going to talk about horizontal and vertical lines. And I'll remind you as we talked in lesson 5 that a horizontal line has a 0 slope and a vertical line has an undefined slope. Well, it's a little hard to see, but they do have a graph of a horizontal and a vertical line. I'm wondering about the equation of those lines. Sometimes it can be kind of hard to remember how to write the equation. But I'm going to go take you back to when you were in middle school and you graphed by using your T-chart. If I looked at the points on this line, would you agree this first point here, I am at 0, 1. 1, 1. 2, 1. You might start to see the pattern that no matter what, I am always going to be 1 unit up from my x-axis, or that my y value would always have to equal 1. That is the equation of my horizontal line. It is always going to be y equals, and whatever your y-intercept is. My vertical line, well, vertical line does not have an y-intercept. But again, if I think about that T-chart, as I look at my points, this is the point negative 1, 0, or the point negative 1, 1, or negative 1, 2. Again, you can kind of start to see the pattern. No matter what, my x value is going to have to be negative 1. I am always going to be 1 unit left of the y-axis. So the equation here is simply going to be x equals negative 1. In example D, when they ask me to write the equations of my horizontal or vertical lines, number 1 says that we have a line with a slope of 0 and it passes through the point 4, 6. Well, slope of 0 tells me horizontal line. And if I just take a second to think about the point 4, 6, I can see that no matter what, I'm going to have to be 6 units above my x-axis. So my equation there is going to be y equals 6. The second one asks me to write an equation of a vertical line that passes through the point negative 3, 4. Well, negative 3, 4, vertical line, I can see I'm always going to have to be 3 units to the left. Therefore, my equation would be x equals negative 3. Finally, we're going to talk about some pairs of lines, and we discussed a little bit in lesson 5 about parallel lines. We said that parallel lines have to have the same slope. And so when I'm looking at my equations, when I'm comparing y equals 4x plus 8 and y equals 4x minus 3 would be an example of lines that are parallel because they have the same slope. Intersecting lines, well, intersecting lines simply are going to have different slopes. So it may look something as y equals 7x minus 5 and y equals 1/4 x plus 2. These have different slopes. They will eventually intersect. Now you may want to make a note that in lesson 5 we talked about perpendicular lines and the fact that their slopes are opposite reciprocals. And so if one slope was a slope of 7, the other one would have to be negative 1/7, the opposite reciprocal. Coinciding lines, well, coinciding lines may look something like y equals 2x minus 4 and y equals 2x minus 4. What does that mean? Well, coinciding lines are actually the same line. Now in example E, we are trying to determine if our lines are parallel, intersecting, or coinciding. They give me equations for 2 different lines. So as I look at number 1, I have y equals 3x plus 7 and y equals negative 3x minus 4. Here's my break. I have 2 different lines there. I can compare these because they are both written in slope-intersect form. They both are written y equals mx plus b. I see this one has a slope of 3 and this one has a slope of negative 3. Well, what does that mean? With a different slope, these are going to intersect. The second one isn't quite as nice because when I look, I cannot say that my slope is negative 4. It's not written in the correct form. So I would have to start by solving for y. I would add x to both sides. I would divide by 2. And I find out that y equals 2x plus 8. Now on the second equation, this is written in point slope. But again, I need to make sure that it is all written in the same form. So I need to go ahead and simplify. And what I find, not only do I have the same slope, but I have the same y-intercept as well. And so these are actually going to be the same line. Finally, in example F, they're asking me to write an equation, again in slope-intercept form, for the line perpendicular to y equals negative 2x plus 8, that contains the point negative 3, 7. Well, slope-intercept form, we want y by itself. If it is going to be perpendicular to this line, I always say that a starting point is to think about your slope. This line has a slope of negative 2, but our line is going to be perpendicular to that. So we're not going to use a slope of negative 2, but we're going to use a slope of positive 1 over 2, the opposite reciprocal. It contains the point negative 3, 7, so that's actually going to be our x1, y1. Now I have a point and a slope. I'm going to plug that into point-slope form and then simplify. So we are going to start by saying y minus 7 equals 1/2 times x minus a minus 3. I am going to need to get y by itself. I'm going to distribute. And then I'm going to add 7. So my final answer, y equals 1/2 x plus 8.5, tells me a slope of 1/2 and a y-intercept of 8.5. So I'm crossing the y-axis at 8.5. If you have more questions on the equations of lines, please stop in and see me or check out the other online videos sponsored by our